Can area models of multiplication be linked to factoring polynomials? NC Squared has the wonderful opportunity to partner with classroom teachers to reflect on mathematics teaching and learning to enhance student understanding. When we work with elementary teachers, we are often asked, why do the Common Core standards emphasize teaching students the area model of multiplication? Or how soon can we begin to teach the standard algorithm? This presentation will explore some possible answers to these questions. Area models can play an important role in a student's ability to work flexibly with numbers and can bridge to algebraic understanding. Decomposing one factor to make simpler problems helps students think about multiplication as a series of easier problems. For instance, let's begin with an example of a one-digit by one-digit multiplication. A student may consider 8 times 7 as two simpler problems by decomposing the 7 into 5 and 2, and then multiplying 8 times 5 to get 40, and 8 times 2 to arrive at 16. The 40 and 16 can then be added together to equal 56. This area model connects to the distributive property. The same model also works for multi-digit multiplication. Take 18 times 12, for example. A student may decompose the 12 into one 10 and two ones, and the 18 into one 10 and 8 ones. Then multiply 10 times 10 to get 100, 10 times 2 to arrive at 20, 8 times 10 to get 80, and 8 times 2 to make 16. This can also be illustrated with the distributive property, where 10 times 10 equals 100, 10 times 2 equals 20, 8 times 10 equals 80, and 8 times 2 equals 16. Adding the four products together equals 216. So how does this link to algebra? The same area model lends itself to multiplication of algebraic expressions. Let's consider x plus 3 times x plus 2. Place x plus 3 along one side of the model and x plus 2 along the other. As before, this highlights that four sets of factors need to be multiplied together, resulting in four terms. X times x is x squared, x times 2 is 2x, 3 times x is 3x, and 3 times 2 is 6. Linking the distributive property to the model highlights the four resulting factors. Once like terms are added together, the simplified expression becomes x squared plus 5x plus 6. You may want to try this problem on your own. Let's examine if the same process will work for factoring a polynomial. How can we factor the polynomial x squared plus 6x plus 8 using the area model? From previous experience with numbers and variables, we know that one way to get x squared is to multiply x times x. Next, place 8 in the lower right-hand box. In order to find the other two terms, consider the factors of 8. 1 times 8, 2 times 4, and the negative factors. And the add-ins of 6. 1 plus 5, 2 plus 4, and 3 plus 3. In this case, 2 and 4 will work because they meet both constraints. Place the 2 along the top edge of the box and 4 along the side, or vice versa. Complete the multiplication to get 4x in one box and 2x in the remaining box. The factored form becomes x plus 2 times x plus 4. Keep in mind that providing your students with multiple opportunities to work with area models can develop their flexibility with numbers and create a foundation for factoring polynomials. You may want to try this problem on your own. For other interesting uses of flexibility with numbers, view Joe Bowler's video, What is Number Sense, at the link shown here. Thank you for your interest.